Hello and welcome to this module in the Tetration video series. My name is Rob and I'm here with my colleague Tim, and in this session we're going to be expanding on the Tetration inventory to cover the concept of filters. Now Tim, in some of the other modules in this series we've talked to some of the basics around the Tetration inventory, the ability to define attributes against that inventory and to use those to actually build out a scope structure or a hierarchy that we use for a variety of purposes, but it's really one of the primary constructs for policy. So in this module we're going to expand on that, talk to filters and how they can be used in conjunction with scopes, and to give you a much more flexible set of methods that you can actually construct policy within and across scopes as well.
Sounds good. Show me it.
Now we have an analogy around breaking down a very large environment into something that's very specific and very human understandable. And in the case of the world that we live in, that's really the addressing concept, a hierarchy that gives you a very specific location based on matching a series of components here as you step through the hierarchy. So what we can do with filters, or what filters allows us to do, is to be able to run a query against the existing scope tree. Now in this case, in the example here, we'll be able to run a filter that's targeting a specific location. Now a location, and again you could consider this in terms of a leaf scope in a scope tree, or any scope in the tree as well. And here we're able to define a query that says we're looking for people with a specific attribute, in this case green people at this location, and the filter will filter out for us and collect for us who are those people that match those criteria. And we could use the same for workloads that exist in a scope in the scope tree.
So it gives me the capability to take an existing scope and narrow it down further based on the attributes of the workload in that scope.
Correct.
But without having to create an entire new scope to represent those objects.
That's correct. And in a lot of cases this is using some of the other attributes that we actually have, that we know about the workloads in particular. It may not be the attributes that we've used to define the scope tree. It could be based on information we get from the agent, as an example. What operating system is actually running there? Or it could be a combination of those things that we're really trying to refine a specific view for a subset of those particular workloads. And we can also use that same concept to match not only at a specific location but across all locations. And in here we're actually saying, well, we'd like to actually define a query against a different attribute. Again, it could be a combination of attributes. In this case it's the blue people that exist anywhere in this environment, and that's going to collect for us that group. Now similarly in the workloads relating to scopes space, and we'll see a couple of examples in the moment, this enables us to basically work across scopes to build matches that are scope independent.
Sounds interesting. How about we try put that on the whiteboard and see what that looks like?
That would be very interesting.
So I'm going to draw a scope tree on the whiteboard here. But I'm going to do it in a slightly different way than we've been used to in some of the other modules. Rather than doing a tree-like structure, I'm going to do concentric circles to represent a narrowing scope tree.
So, Tim, is that conceptually similar to looking the top-down view of the scope tree?
Exactly.
Yeah, okay.
And this will help us also understand about the fact that scopes themselves are not supposed to be overlapping. An endpoint should always belong to only one part of the scope tree. So if we draw a circle for our scope tree, and then we draw a couple more circles inside there. 1, 2, 3, 4. These might be subscopes. This could be applications, services, partners, whatever you would like to do. And you might have a couple of endpoints that sit inside those different scopes. So you might have an endpoint here, 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 and here. Now, these endpoints can never belong to more than one scope, as we know. So if I wanted to group these two endpoints together, but conceptually they belong in different scopes, this is where I might want to use a filter to actually represent that particular matching of endpoints together. So let's say that these ones over here, this is a Windows server, this is a Windows server, this is a Linux server, this is another Linux server. These are databases, and these are web servers. If I wanted to select across all of these different scopes for just my Windows servers, I could create a filter to select based on the OS version being Windows. And that would create a new object that selects endpoints across those scopes, without having to break that rule of not allowing scopes to go in, or endpoints to go into multiple scopes. I can still apply policies to all of those Windows machines, no matter what scope they fall in. In the same way, if I wanted to select databases, just databases, whether they are Linux or Windows databases, I could create another filter that would be able to filter these database servers as well. And you can see in this case, it is totally permitted for an endpoint to be both in the Windows filter and in the databases filter.
Okay, so that allows us to create and apply policy according to whatever sort of business or security demands that we have that are independent of the actual scope structure, but will be applied to those workloads wherever they reside.
Exactly.
Okay, excellent. So let's have a look at it, maybe expand that out in terms of a couple of examples that relate to our sample or example scope structure. In this case, we've got, yes, a match to the operating system, but also we're only really focusing on those that are in production. Now, we've got different annotations that are assigned to the workloads themselves. One of those is the environment. It's going to specify whether it's prod or non-prod, as an example. That may have a bearing on the scope tree and where it resides there as well. And then we derive from the agent the operating system version. So in this case, because we're actually doing this as something that's attached to the root scope, so we're creating a filter and we're associating that the root scope level, it means it applies throughout. So any workload that has this combination, regardless of what scope it's in, so the environment of prod and the operating system matching Windows Server 2016 will be pulled into this group. And then we can apply a policy specific to that group, to which those machines and those machines only will actually receive that policy.
So for example, here I could write a policy that says all of my production Windows machines are allowed to access my production Active Directory server, without having to replicate that policy into each one of those individual scopes.
That is correct.
Okay.
Yep.
Starting to see why this would be useful.
Yeah. So that policy will apply to basically the workloads that require the policy in the environment. Now, similarly, we could have a more specific query. In this case, we've got what we know is our IT services group. Now, let's just say we haven't actually broken out NTP as a particular grouping at this point, but we know that there are traffic flows that are going to IT services. They haven't been otherwise scoped, and we might want to actually just create a group to hold that, or apply it for different purposes. But creating that as a filter means that we can very quickly identify those particular workloads. In this case, what we're going to do is we're going to match on a host name, because in this case, the host name being reported from the agent, if it matches NTP, then it's going to be pulled into this group as if it's part of that scope. So this is a scope-dependent query. It's associated directly to that. We can then offer the NTP servers, in this case, that group, as a provided service. So that can then be consumed by other workloads in the environment.
So you're saying, even if I had other machines in my data center that had the host name containing NTP, only those that were part of the IT services scope would actually match that query because you restricted it?
That is correct, yep.
And in terms of the query that I can use all of the attributes we've associated from the endpoint?
Yeah, so the actual query, the queries themselves can be across anything that's associated to that particular workload in the inventory. So we know about the annotations, the things that we've applied there. We know about the tags and other things that we've derived from the hypervisor, from the cloud. So they've come in through the orchestrators, as an example. We also get the information that the operating system itself provides, and we've seen examples of that with host name, operating system version as well, but we also see what processes are running there, the process hashes as well. You can query across all of those attributes or elements of a given workload to be able to very specifically identify workloads that you want to actually group for policy purposes.
Does that even mean I can group workloads that have vulnerabilities associated with them?
Yes, yeah. So we will explore the actual workload details and what we actually derive from agents in the agents module, but we do derive not only the process information but the packages. We associate that with known vulnerabilities, and the query can be across all of those as well. So it could be, I want to match Windows workloads that have this specific package loaded on them. I want to maybe simply identify all the workloads in my environment. I can query and search for anything that has a given vulnerability associated to it, and I can then build a filter to apply policy against those. And that's a great way when that next vulnerability drops in about 5 seconds' time to be able to identify, A, do we have this vulnerability in our environment? B, what sort of controls do we want to put in place to actually be able to protect ourselves from that potentially being exploited? And that's even until such time as that maybe that is patched and the vulnerability is then no longer matching. And that's how these queries dynamically update, so with the current state.
Okay. It seems like a very powerful tool for the administrative staff to be able to keep control over applications and the workloads that are part of the applications without having to go and deal with policies on each application by application basis.
Exactly. You basically can write a query which may today match to 20 workloads. As those workloads change, and again with the case of vulnerabilities, maybe they're patched, that's 15, 10, 5, and then ultimately that no longer exists and the membership is 0. But the policy constructs are very easy to write, and you can then apply them at the appropriate point in the scope tree to again apply hierarchically to everything below.
Okay.
So how do we create these filters? And we've seen these two examples, and again very simple examples, but hopefully it gives an idea of the power of this. We have two ways that we can define them, and in this case the first one was match all production Windows 2016 hosts, and we did that by identifying or associating it to the root scope. So the root scope being the global sort of root of the whole tree, applies to everything, and you can see here that we're not restricting the query to that scope, it's applied to all. Okay, and by doing that, when these queries are applied, so the environment match, the OS match, it will look through the entire inventory and it will create a group with this name, a filter, that is the object that contains each of those workloads or machines. Similarly, in the more specific case, we actually had a filter that was built around a very specific scope. And this gives us the ability to attach the query to the scope. So again, we're restricting it there. We're not matching things outside of that scope.
Okay.
And it allows us to optionally provide that as a service that can be consumed by others for policy purposes.
And I'm assuming we're going to go into some more detail about what providing a service means later.
Yes, so we will have subsequent modules that will talk through policy, how policy is defined, and how we can exchange policy between different groups and apply it at different levels in the hierarchy.
Fantastic. I know a lot more about filters now.
Excellent. Thank you. That concludes this session on tetration filters. For more information, please go to cisco.com/go/tetration. Thank you.